Hey guys, today we're going to be talking about the set reset flip-flop or the SR flip-flop. So the SR flip-flop is a sequential switching circuit which makes the output, shown here as Q and Q prime, depend on S, the clock, and R. So without S, clock, and R, we cannot know the output. I want you guys to think of the SR flip-flop as the light switches we have in our house. So this is when it's off, and this is when it's on. The S also stands for set, which also stands for on in terms of this light bulb example. So let's put S by the side. And the R stands for reset, which is same thing as off for this light bulb example. So let's try making a table out of this. So we have our S, we have our R, and we have our next state because we want to know what's going to happen next. And between S and R we have 4 combinations, which are 0 0 0 1 1 0 and 1 1, and I want to know what's going to happen next. For the first row, we see that our set is 0 and our reset is 0. And again, I want you to know that this is how our reset state looks like, and this is how our set state looks like. So right now, I want you to imagine that you didn't set it because your S is 0 and you didn't reset it. Your R is equal to 0. So what happens to the bulb? Exactly nothing. So if this bulb was switched off before, it's still going to be off. But if this bulb was on before, it's still going to be on because like you didn't do anything to like trigger any action. So for here, nothing happens. Let's go to the second row. Now we see our S is equal to 0 and our R is equal to 1. This is how our R state looks like. So what do you think is going to happen to this bulb right here? Of course, it's going to be reset, right? So that means no matter what happens, so if this bulb was shining before and you put it in the reset state, it's going to switch off. And now we know that off is the same thing as 0. So this is 0 because your reset is 1. And now our S is 1 and our reset is 0. So it's just the S that's 1. This is how our set state looks like. This is when the bulb shines. So even if this bulb was off before and you put it in the set state, it's going to start shining. So now you put it in the set state, which is the same thing as 1, and you're going to make the bulb shine. So that's what the set does. The set state makes the bulb to come on, and when the bulb come on, it's the same thing as 1. So we'll put 1 here. Let's go to the fourth row. Our set is 1 and our reset is 1. This is a tricky part. You just have one switch. How can you perform 2 actions with one switch? How do you want to put the switch on and switch off at the same time? It's impossible. So just because of that, you can't do 2 actions at the same time, and here we say that it is not allowed because it is impossible to make 2 actions on the same switch. You can't put a switch on and off at the same time. It's impossible. So that's why we say here it is not allowed. And that is the reason why when S is 1 and R is 1, such kind of thing is not allowed. We have 2 kind of flip-flops in general. We have the rising edge flip-flop and we have the falling edge flip-flop. And this is the falling edge flip-flop because of the circle we see here. So anytime we see a circle schematically in such kind of flip-flops, we know that it's a falling edge flip-flop. And here, because there's no circle, we know that this is the rising edge flip-flop or the rising edge triggered flip-flop. So right now I want you guys to see the differences between these 2 flip-flops. So this is a timing diagram to show the difference, and let's see how the clock behaves and how the flip-flop is triggered. So you know how in your mechanical clock it makes like the sound tick tock tick tock. I want you to like have it in your head and make a flip-flop kind of sound, you know, because that helps you in like understanding what I'm about to do. So let's try doing it. We have the flip, flop, flip, flop, flip, flop. Same thing here. Flip, flop, flip, flop, flip, flop. When the rising edge is triggered, the clock goes from 0 to 1. But when the falling edge is triggered, the clock goes from 1 to 0. And we know that this is 0 and this is 1. So here is the rising edge This is the rising edge, goes from 0 to 1. This is also the rising edge, goes from 0 to 1. And from 1 to 0 for the falling edge, this is the falling edge because it goes from 1 to 0. This is the falling edge, and this is also the falling edge. So just imagine a command passes through here and it gets to this trigger. The trigger initiates another command. Just imagine that command gets to another trigger. That trigger initiates another command. So that's just basically what's happening in like the falling edge and the rising edge trigger flip-flop. So now let's say this yellow arrow represents a command. So the mixture of these two commands creates an output of Q. So it overrides the system and creates this output, leaving out like the previous command of Q. So it doesn't matter. So this S and R, when combined, overrides the system and brings out a value, arrow. And now let's say this pink arrow represents another combination of S and R. And now that comes out here from Q. And same thing with this green arrow. They bring out a combination of commands, and that comes out through here. So let's make a table for this. We have our S, we have our R, we have our Q, and we have our Q plus. I want you to know that Q plus represents the next state and Q represents the present state. I'll just put PS. So now you see the first line of command are these yellow arrows we put in, and is represented here on the table. But for the present state of Q, the first state of Q brings out nothing, because I told you that this two arrows overrides the system and brings out a combination of the two arrows. So if S was 1 and R is 0, it's going to come out as 1. If S was 0 and R is 1, it's going to come out as 0. So this yellow arrow is like the output of S and R. But initially there was nothing down there. So we're going to leave this place blank. So this overrides the system and brings out this yellow arrow. And now we're going to go to the second string of commands. And for the second string of commands, we see now our previous state is the yellow arrow, because now we are jumping from here to here. So our previous state was the yellow arrow. So we're going to put the yellow arrow here. And our inputs were this, the pink arrows for S and R. And then Q plus is a combination of the pink arrows, and it's going to give you this. And now let's go to the green arrow. This is our third line of command. We see for the third line of command, our previous state is now the pink arrow. So this is your present state, the present state is now the pink arrow for the third line of command. And for the third line, we have S as the green arrow, R as the green arrow, and the combination of S and R, Q, as a green arrow. So I hope this gives you a clear understanding of like what's going on in the SR flip-flop. So let's try having an example. We have our clock. It goes flip, flop, flip, flop, flip, flop, flip, flop. And because this is a rising edge triggered flip-flop, this timing diagram is going to be activated only when the clock goes from 0 to 1. And now we have S, we have R, and we are trying to find Q plus because we're trying to find the next state. The first thing you need to do is draw the table. We have S, R, and we have action. 0, 0, 0, 1, 1, 0, 1, 1. What happens at 0, 0? Nothing. What happens at 0, 1? When R is 1, the same thing as when it's switched off, so that's 0. When S is 1 and R is 0, the same thing as like switched on, that's 1. And for this, there's nothing we can do about it because it's not allowed. So it's this table that we're going to use to like find our Q. Sometimes your teacher gives you the first bit of Q, but in case you're not given, just imagine that your first bit of Q is 0. Because your Q has not been activated, it hasn't been triggered by any of these triggered lines. And since it hasn't been activated, it's safe for you to just assume that your Q is 0. So your Q is 0 and it goes to the first activation line, And so before we find Q plus, let's label S and R. And it's always safe to label S and R close to the activation lines. It's actually like the best way. So let's label S here. We see that S is 0. And here we see that S is 1. Here we see that S is 0. And here we see that S is 1. So S is equal to 0, 1, 0, 1. And for R, we see that here it is 1. Here 0, here 0, here 0. And R, we know that it is 1, 0, 0, 0. So before we even look for Q plus in the timing diagram, we should be able to know what Q plus is just from this information we've gotten. So let's try finding out. When S is 0 and R is 0, so in the first bit we see that S is 0 and R is 1. 0, 1 is going to give you 0, right? And here we see S is 1, R is 0. 1, 0 will give you 1. Put 1 here. So for the third bit, we have S is 0 and R is 0. So we'll come here, look, S 0, R 0. So, and there's no action. But we need to be very careful. Remember I told you that when the bulb is shining and we have no action, the bulb will continue to shine. And remember I told you that when the bulb is shining, we should think about it as 1. And if there's no action, it will continue to be 1. So right now, since there's no action, the next state, or Q plus, is going to be equal to your previous state, which is 1. And finally, let's look at 1 and 0. 1, 0, action 1. Your Q plus last bit is going to be 1. So let's see if we can get the same value. Remember I told you your Q plus is going to start with 0. Starts at 0. And then here's the trigger line. We have 0, 1. Let's try looking for 0, 1. So this is 0, 1. Your action is 0. So it's still going to continue till the next trigger line. This is the next trigger line. Now your S is 1. And your R is 0. Action 1. So it's going to jump to 1. And I'm going to continue to the next trigger line. But guys, I want you to know that this is still correct, but I mean, like, logically, in an engineer's point of view, is wrong, because we always need delay times. Not every part of a machine works at the same time, so there's always a delay, and for that we need to like put it in a timing diagram. So the space between the yellow and the pink line is called the propagation delay. It's always good to put in the propagation delay to avoid any unpredictability. So let's continue with this. It's going to be constant to the next trigger line. And at this trigger line, we see it's 0, 0. So S is 0, 0. And remember, nothing is going to happen. There's no action taking place when S is 0 and 0. So it's going to continue. And it's going to get to this trigger line, and we see that now S is 1 and R is 0, so the action is going to be 1, so it's going to continue. And let's see how this correlates with our answer. So remember I told you to always put your binary values close to the trigger lines. So Q started out as 0 because it wasn't activated, and when it was activated it became 0, and then it continued. We had to give it some delay and it became 1. It's still close to the trigger line, but we need to consider that delay. And here it continued being 1, and here it continued being 1, and we have 0, 1, 1, 1. That's Q plus. The binary equation for Q plus is equal to S plus R prime Q. Remember, this is the next state and this is the present state. Therefore, the next state is dependent on S, R, or R prime in this case, and Q. And you see, we needed Q right here because it was 1 here and we did nothing. There was no action. So we needed to copy this value and put it here. So that's one of the reasons why we need Q in this flip-flop. Because in reality, in this case, this was the Q and this was the Q plus, and this Q plus depended on this Q, because in reality when we did nothing between these two, this was the Q plus and this was the Q. So right now we're going to use this binary equation to find this Q plus. We are going to need S, R, and we're going to need Q to find Q plus. So let's do it. Our S is equal to 0 plus R prime. Here it was 0. So if you make a prime of that, it's going to give you 1 times Q, your previous state, which is 1 here. 1. And that is equal to 1. So if you want to do it bit by bit, you can use the binary equation, which is a very stressful thing to do. The best bet is just use a table and either use a timing diagram. I mean, any one of these two is better than just like plug in each binary bit into this equation. Alright guys, that's it about SR flip-flops. If you guys have any questions, comments, or you want me to make a video on any topic you do not understand, please leave a comment in the comment section below. Have a nice day. That's a smiley face for you guys, and peace.